So what are we here for tonight, you guys? We are here for the one, the only, this guy, at least in my corner of the screen right there, Brian Grant, who is from Oregon. So we're all Oregonians today, one of our locals. So Brian is always fantastic to have speak. He joins us every year without fail. So thank you, Brian, for joining us and for diving into demystifying DAX. How many D's can we use in a sentence? I'm not sure. I definitely want to encourage you guys. Brian's been pushing out some great blogs at briangrantbi.blog. He's been sharing those on his LinkedIn. So give him a follow and check out that blog and subscribe. Brian, I want to invite you to the screen and invite everybody to welcome Brian Grant.
Hello, everybody. Good to see everybody. Sort of see everybody. I can see exactly half of you. Welcome to my debut as a proper Bond villain. In that, the most torturous thing I could think of to do is about an hour and a half PowerPoint. So here we go. Let me go ahead and share my screen. So hey, welcome everybody. So we're going to be talking DAX physics, not fancy physics, just DAX physics 101. We're going to be demystifying the DAX evaluation, demystifying DAX evaluation context. Hey, that's me. Okay, so just a little background for this presentation. People have been asking me pretty much forever to write a book. It's very difficult to write a book on anything in Power BI, in particular DAX, mainly because there's already a lot of good books out there. So what are you even going to write about? So I decided that the way that I wanted to approach this was to create a blog that would act essentially as a first draft. So as Tina mentioned before, if you've been following me on LinkedIn, which you should be, I have been posting pretty regularly new blog posts, but really the blog posts are just kind of chapters of the book. So I did that for a couple reasons. I wanted to have some way to get my ideas out on paper, if you want to call that paper, while I could use that to work out specifics about where and how certain ideas were introduced, right? So this presentation you're going to see right now is basically a summarization of a big chunk of the content of that book that I've been creating out on my blog. So it's kind of compressed all together. So if you like what you see here, go check out the blog, right? Okay, so let's talk about evaluation context. The first thing to know about evaluation context is that it is terrifying. Oh no, evaluation context. It's not so much that the concept's terrifying. What's really scary is the name. I don't know who came up with it, but anything called evaluation context is not going to make a lot of friends at the cocktail party. So don't get me wrong, the evaluation context, the concept part of it, not the name, is indeed tricky, but mere mortals like you and me can absolutely understand it. If you can understand the concept of a list of groceries, you can understand evaluation context, I promise. So this, and by this I mean evaluation context, is a core concept of DAX. So if you do the work to understand it, you're going to start to see DAX not as a giant, angry, spiteful god prone to whims of fury and destruction, but instead you're going to see DAX as a simple machine that moves tables around in the exact way that you ask it to. Simple as that. Okay. There's a problem though. One does not simply just learn evaluation context. And by that, I don't mean that it's impossible to learn it. I mean that you have to learn a few other things first, right? So there's a couple concepts we have to put underneath it before we can even start talking about evaluation context. So with that in mind, let's go through what we're going to be covering over the course of the next, I don't know, hour and a half or so. So the first thing we're going to be talking about is table references in DAX, and specifically how when you type in the name of a table in DAX, what you get is probably different than what you're thinking that you get or expecting that you get. Once we do that, we're going to talk about subformulas, also called sub-expressions. The idea here is in DAX, what often looks like one big formula is actually several smaller formulas chained together, right? Now, once we have those two things figured out, we're going to be able to learn about evaluation context and how evaluation context is essentially metadata that gets used by these subformulas to produce the numbers that we want to see in DAX. Okay. So let's level set. Where are we on Mount DAX here? So on Mount DAX, one section of Mount DAX you might call practical DAX. So in practical DAX, they teach you how to solve very simple, common, everyday problems. When you have this problem, you use this function. When you have this problem, you use this function. Practical DAX is great, but if there's not a function that solves your problem, you get kind of stuck. So this is not a presentation on practical DAX. Also on the mountain is what we might call advanced DAX. If this were an advanced DAX presentation, we would be focusing on very, very deep mechanical understandings of things. It's very, very hard to learn. However, it's also extremely powerful, but it's a little too difficult for where I want to go today. Where we're going to be today, we might call advanced DAX prep. So think DAX Physics 101. Yes, this is a physics presentation, but it's like the 101 version where like you have the bowling ball roll down the thing and hit the whatever, right? This is for the people that don't want to be physicists, but you need to know just enough of it to move on to those more advanced concepts, okay? So we're going to introduce hard ideas slowly. We're going to use both strategic simplifications, simplifying things where it makes sense, and also friendly language. We're not always going to use the most technical terms because, frankly, the most technical terms are often not helpful. You can learn those later on when you're up here getting cold at the top of the mountain. Okay, so let's go learn about table references. This is setting things up part 1. So here's the data model that we're going to be working with today. Pretty similar if you guys have been following my stuff at all. This is for a fictitious restaurant. In this fictitious restaurant, they've only had 7 sales transactions, so they're probably going out of business pretty soon. But in each sales transaction here in the sale table, we can see the shift that the sales transaction happened in, what they when they ordered it. We could see how many they ordered. We could see what the price of the dish was, and we could see the dish that they ordered, whether they ordered pasta, burger, or one person actually ordered a salad. In addition, we also have a dish table, and in that dish table, this acts as a lookup table to the sale table, right? Wherein, based on what's called the dish ID here, which is really just the dish, we could go look up additional information such as the type of the dish. Is it a regular dish or the house special, which for this restaurant is the hamburger, not a very good sign. And we can also look up the cost of each individual dish. So if you're an Excel person, you would think of this as a data table and this as a lookup table, right? If you're a BI person, you will think of this as a fact table and this as a dimension table. Any one of those definitions is just fine. In between these two tables, we have a Power BI relationship, which I've got here. So we've got a many-to-one relationship. And here it says LU because this is a lookup relationship. So when you create a relationship from one table to another, you're essentially allowing lookups to happen. Because we have a relationship between these two tables, since I know what dish every single person ordered, I can also tell you what type of dish it was, and I can tell you what the cost was for each transaction. Okay? All right, enough on the data. Let's go do some more fun stuff. So DAX is a language of tables. The thing is, though, there's lots of different kinds of tables. So when somebody says, hey, could you point at a table in DAX? It's kind of a trick question because there's different kinds of tables you can be looking at. So we have to get good at spotting those different kinds of tables. So I'm going to go back here, right? So there's 4 kinds of tables in DAX and a little bit of Power BI that we're going to be focused on that you need to be able to distinguish when you see them out in the wild, right? The first I call a model table. You'll sometimes hear these called physical tables of the data model. These are the tables of data that you load into Power BI from a place like Excel or SQL. So on the far left-hand side of your screen, there's a little icon where you can see the data viewer. If you go there, you can see these tables, right? This is the cleaned up but raw-ish data that you're going to use to create your visuals. Speaking of which, another very important kind of table is a table visual. So when you create a visual in Power BI and you say, I don't want a column chart, I don't want a line chart, I want a table. Yes, that is a table, but specifically that is a table visual, which is different than a model table. This is the raw data that gets summarized. The table visual is a presentation of summarized data in table form, right? So these table visuals, these are also very, very easy to see. Anytime you have a table visual in Power BI, that's what this is, right? Okay, but there's 2 other kinds of tables that are important for us to understand, right? One important one I call a summary table. A lot of times in the documentation, you'll call this the result of a DAX query. The idea is whenever Power BI needs to draw a visual, be it a table visual or a line chart or a column chart or anything like that, it needs from the DAX engine to get a summarized version of our detailed data that it will then draw as a line chart, as a column chart, or a matrix, or a table, or whatever it is. So the job of the DAX engine is to produce these summary tables, which Power BI then draws. So the model tables are the cleaned, detailed version of our data. The summary tables are just what they say, summarizations that get drawn by Power BI, right? One more kind. It's very, very important. In fact, it's maybe the most important. I call this a temp table. Other folks will call these virtual tables. In the documentation, these will be called table values. Whatever you want to call it, these are tables that exist only temporarily while DAX is producing these summary tables. So the DAX engine takes our raw data and summarizes it. And in the process of summarizing it, there will be a bunch of temporary tables that get created and destroyed that DAX uses to produce the final results. These are the most important, and guess what? You can't see them in Power BI. All these other tables you can see. I can see this table over in the table view on the left-hand side of the screen. I can see table visuals on the canvas. Now, with Power BI Query View, I can actually see summary tables. The one kind of table I can't see is the temp tables. They're very, very important. But don't worry, I'm going to show you just what they look like. Okay? So, any questions about what I've talked about so far? Is this making sense? Table visual. Baby matrix. Yeah, a little baby matrix. That's exactly right. Yeah. Okay, so most functions in DAX are designed to work with these temporary tables. That's why it's so important to understand them. There's actually only a few small handful of functions that work with the model tables. Why does that matter? Well, let me show you a little bit of a puzzle, right? Hopefully that'll make things a little clearer. So let's say that we've got a Power BI visual that looks like this, a card right here. It says total transactions. It's using the total transactions measure, and it's coming up with a number 2. And if we notice underneath, we got these 2 slicers. The user has clicked on the slicer for lunch, and they've clicked on the slicer for the house special, which, if you remember, is the hamburger, right? So the definition of the total transactions measure is quite simple. Total transaction is count rows of sale. Well, that's not too tricky. So let me ask you a question. Here's my puzzle, right? Or my trick question, maybe, if you will. What are we counting the rows of? Brian, what do you mean, what are we counting the rows of? It says right there, count rows sale. Of course, we are counting the rows of the sale table. I loaded a table from Excel. I named it sale. I could go see it in the left-hand corner of my screen. It looks like this. It says to count rows of sale. That's a thing called sale. That's what we're counting, right? Good guess, but no. So here's the thing. This sale table right here, this is the raw version of our data. It's got 7 rows and 4 columns. And if you notice the thing, it says count rows right here. Count rows is returning the number 2. Well, this right here, this is all of our rows, not just the lunch or house special rows. So in order to correctly produce this number, what DAX has to do is it has to create a different table, a logical copy of this table with columns added and filters applied, right? It adds the columns so that it can apply all the filters. Why? Because we want this to say the number 2 right here, because when we click on things, we want our measure to respond to slicers. So because when we count the rows of sale, we're always getting a filtered copy of the sale table. Because the copy is filtered, that's why the number is constantly shifting, okay? Let's be a little clear about that. Oh, by default, when you type in the name of a table in DAX, what DAX gives you is a filtered copy of that table. Technically, it's a filtered logical copy for the very technical folks in the room, but don't worry about that. Just think copy like in Excel, Control-C, Control-V, okay? So when I type in count row sale, here where it says sale, what DAX is giving me is a copy of our sale table that looks like this. The copy is filtered because when the user clicks on slicers, we need to get different numbers. So by filtering the copy, that's how we get different numbers. The copy that we've got has these columns added over on the left-hand side. The sale table only has 1, 2, 3, 4 columns normally, but the copy that we get adds all the columns of the dish table because we might have a filter on one of the dish columns. Like down here, we have a filter on house special. By adding these extra columns, now the filter for house special has a column to filter on that copy right there. Now, all this may seem very strange, but it's not quite as strange as it at first appears. In fact, it's very, very Excel-like, which is good because I come from an Excel background, right? So let's imagine that we're in Excel, right? And in Excel, we open up a fresh workbook, and in the cell A1, we type in the following formula, equals 2 plus 3. We hit enter, and we get the number 5 because 2 plus 3 equals 5, right? Okay, so let's think about that cell. The cell A1 actually has lots of different things in it. The most obvious thing is what's called the value of that cell, the number 5. But there's actually lots of different pieces of information in there. So in the cell A1, there's things like the cell name. There's things like the row number of that cell. There's things like the column number of that cell. That cell also stores inside of it the formula that is used to produce the value. All these other bits of information are in the cell A1. And yet, If you, in a different cell, like over here in C1, you type in equals A1 times 10, that cell reference of A1 knows that even though this cell has lots of stuff in it, the thing that you want to get out of the cell is the value, right? Why? Because obviously you do. That's the most natural thing in the world. That's why Excel does this automatic behavior for you. When you type in an Excel cell reference, it automatically retrieves the value from that cell, right? However, I should say 99% of the time, this is what you want. There are certain times when you want to retrieve other bits of information out of that cell. You might want to get the row number or the column number or the formula. And in Excel, there are specialty functions like row or column or formula text that will retrieve not the value from the cell, but one of these other pieces of information. Okay, so by default, in Excel, when you type in the name of a cell, it gives you just the value, but there's other stuff you could get from those cells, and you could use specialty functions to get them. Okay, now let's talk about DAX. So here we've got that sale table that I showed you a few minutes ago. This is our very simple sale table, right? Very, very simple. 7 rows and 4 columns. That table has lots of things that you can get out of it, right? You think of it as just a table, but from a programming point of view, there's lots of different things that you could do with that table. It has a name, theoretically, that you could retrieve from it. You could use that table to retrieve a list of columns. That's another piece of information that can be retrieved from the table. You could get an unfiltered copy of it. You could get my dog, who's coming to say hi. Hello, ladies. They're going to hang out for the presentation. Come on, guys. Out. Thank you. You could get an unfiltered copy of the table, right? Or you could get a filtered copy. Lots of different things you could get from that table. And yet, when you type in the name of the table in some DAX function or measure, what DAX gives you by default is the filtered copy. Why? Well, because 99% of the time, this is what you want. That filtered copy is the thing that's going to respond to slicers. Therefore, most of the time, that's the behavior you want, right? If you want one of the other things, you could use specialty functions in DAX, like remove filters or all or is filtered. And these, you could give them the name of the table sale, but they won't get a filtered copy. They might get an unfiltered copy, or they might retrieve a list of column names. They'll get one of those other pieces of information, okay? Okay, so when you type in the name of a table in DAX, even though that table has lots of different stuff you can get out of it, what you get by default is a filtered copy. And I think I'm actually about to say that again. Oh, wait, no, I'm not. What I'm going to tell you right now is how DAX gets that filtered copy, right? So when I do total transactions and I do the count rows of sale, okay, Brian, I believe you that sales gets you a filtered copy, but how does it do it? Well, let me show you, right? It performs 3 steps, 3 simple steps any Excel user can understand. SQL user too, but even Excel users like you and I, right? Step 1 is the simple copy. This is what it sounds like. It makes a copy of the table. So since we're dealing with the sale table here, DAX just makes a copy of it, right, in that temp table format. Hey, look, it's an exact copy. Nothing has been done to it. Nothing has been changed. That's why it's the simple copy. So Excel folks will think of this as a copy-paste. SQL folks can think of this sort of like a select star, right? Okay, that's step 1. Step 2, the super lookup, right? This is also called table expansion. The idea here is because the sale table has a relationship to dish, DAX can automatically use that relationship to essentially VLOOKUP all the columns from dish onto our copy. So we go from this to this. Hey, look, we got those 3 extra columns added onto the side of the copy of our table. SQL folks will think of this as a left join or a left outer join. Excel folks can think of this as a VLOOKUP or an XLOOKUP or a match index if you want. I call it the super lookup because it's like a lookup, but there's a whole lot of them. It does stuff automatically for you. Okay. If you've ever heard the term table expansion before, that's what this is describing. Table expansion is the exact same concept. The idea is this is the table and it kind of inflates outward like a balloon, expanding. Okay. So we've got the simple copy. We've got the super lookup. Last step is auto filtering. The idea with auto filtering is we're going to apply all the filters from things like slicers, right? So if we've got a slicer like this, if you remember where the user has clicked on lunch and H special, well then what DAX is going to do is it's going to take this copy where we've added these columns and apply filters based on what we clicked on. We filter down to lunch and we filter down to how special. We just keep the lunch how special rows. And sure enough, we get this copy down here where we get 2 rows. Which rows? The lunch and how special ones. Now, to add a little bit of complexity here, right? When we do this filtering, it does respond to things like slicers, but there's this layer in the middle. The name of that layer in the middle is the filter context. The idea is when you click on these slicers, DAX internally has sort of like a document or a list that it uses to keep track of what filters it needs to apply. The name of the list of filters that it needs to apply is called the filter context. So when we click on these slicers, DAX writes down that it needs to apply these filters over here. And then during the auto filtering phase, it says, oh, right, which filters do I need to apply? Oh, good, I wrote it down in the filter context. I got to apply a filter for lunch and a filter for house special. Okay, I think I just jumped way ahead of my content here. Yeah, so filter context. The name sounds intimidating, but it's nothing more than the list of filters that DAX needs to apply during that auto filtering phase. That's it. That's all filter context is. Okay. So you may have noticed that the filters in the filter context are not the way that you might think of filters. So if you're a human, you say things like shift equals lunch or type equals house special. That is a normal human way of thinking about it. However, the work of producing these numbers is not done by a human, it's done by a database. And by having the filters in DAX be tables, which is what these are right here, DAX is able to operate a whole lot faster. So let me rephrase that. In DAX, all filters are tables. This is strange for humans. That makes a whole lot of sense for databases. And since its database is doing the work, that's how DAX does things. It allows it to be really, really fast. Really, really fast. Okay. No questions that I see. Fabulous. So how do we get that filtered copy? 3 steps. The simple copy, which is like a Control-C, Control-V, or a select star. The super lookup, which is like a VLOOKUP 1, 2, 3 times, so a super lookup, or if you prefer, a left outer join. The last step is auto filtering. In Excel, this is sort of like in the filtering pane, clicking on the little filter downward triangle things. If you're a SQL person, this is sort of like a where exists. In fact, not sort of like a where exists. It is a where exists internally, right? But you don't need to know that part. All you need to know is we get a copy, we add the columns, and then we apply filters from things like slicers, okay? And that's how we get that filtered copy, okay? What's important to know is anytime you have any function in DAX at all that responds to slicers, it does so internally using these 3 steps right here, right? So if I do the count rows of sales, and that sales reference gives me a filtered copy, it uses these 3 steps. If I use a function like sum or min or max, and that function responds to slicers, it's because internally it is using these 3 steps. If I have a function called dates YTD and it responds to slicers, it's because internally it is using these 3 steps. So these 3 fairly simple, innocuous looking steps, these are the things that allow filtering to work automatically in DAX. Okay, I'll pause. Any questions about what I've talked about so far? You can put it in chat or you can just yell at me. But yell into my left eye, it's my good one.
Don't hesitate to come off mute, you guys.
Hey, watching the chat, nothing just yet. You're just doing such a fantastic job, Brian.
That's right. It's just I nailed it so good. People didn't have any questions. I didn't even talk. What would we even say? Okay, let's keep going. Okay, so takeaways from this section, right? Not too many. Most table references in DAX create a filtered copy of that table, right? I need you to take that away. The list of filters that gets applied in that filtered copy is called the filter context. If you got those 2 things, that's all you need, right? You got the little hands. Yeah, you got it. Exactly. Okay, so setup section number 2, subformulas in DAX, right? So we understand that when we type in the name of a table, we get a filtered copy. Let's talk about subformulas. These are really fun. So DAX is a language of subformulas. Most DAX formulas, not all of them, but most of them actually contain 1 or more subformulas within them. These are just small formulas inside a bigger formula. If I want to use the fancy technical terms, they don't call them formulas and subformulas. They call them expressions and subexpressions. Those terms are kind of overwhelming, though, for new users. If you've written a formula in Excel, congratulations, you get the concept of a formula. If you can imagine a formula inside a larger formula, congratulations, you understand the idea of a subformula. It's not that complicated, okay? So let's talk about these a little bit. There's 2 kinds of subformulas that we care about. Just 2 kinds, right? Per row formulas and new filters formulas. A per row formula is a subformula that runs once per row of a temp table. And a new filters formula is a subformula that runs with a new set of filters. That makes sense given the name, but this is a little wishy-washy. Can we make this a little bit more concrete? Sure we can. Let me show you some examples. So let's talk about per row formulas. Whenever you use an iterator function, like any of the x functions, like sumx or averagex or maxx, by definition, you have to write a per row formula, a subformula that runs once per row, okay? So argument 1, not argument 2, but argument 1 of an iterator is a set of instructions for some temp table. So here for sumx, when I type in this produces a temp table that looks like this. When I have instructions here, argument 1, that's instructions for producing a temp table that looks like that. Any set of instructions that produces a temp table, you can type into argument 1 of an iterator. Then in argument 2, since you've got instructions for producing a temp table, argument 2 is tell me the formula that you would like to run for each row of that table that you just described for me, right? Argument 2 is a per row formula. So argument 1 says, go build this temp table for me. Argument 2 says, and run this formula for each row of that temp table and sum up the results, right? So here in averagex, this is instructions for building a temp table. Then in argument 2, this is the per row formula. Go run this formula for each row of this temp table over here, and then average the results. These are instructions here in maxx. These are instructions for producing a temp table that looks like this. Then in argument 2, we say, okay, this is the formula that I want to run for each row of this table, and I want you to max, go find the biggest number, right? So that's the idea of a per row formula. It is a formula that we want to run once per row of some table, some temp table to be specific. What's the other kind of subformula? A new filters formula. These are always associated with the calculate function, or technically calculate table, but usually calculate. We'll keep things simple. So with the calculate function, whatever you type into argument 1 is a new filters formula. This is a subformula that you would like to run under some new set of filters. So here, when I type in count rows sale, this is the subformula that I want to run with some change made to the filters. What change would I like to make to the filters? Well, that's argument 2. Whenever you type into argument 2, or arguments 2, 3, 4, 5, 500, are the changes that you would like to make to the filters before you run that new filters formula. So here, we're going to count rows of sale after we remove any filter on sale shift. Here, we've got instructions for producing a temp table. And so when you give that to calculate, it says, I want to go run this subformula after I add this as a filter, right? So here with calculate, this is the new filters formula, what we want to run after we change the filters. Argument 2 is instructions for the temp table that we want to add as a filter. Go run this after you add this as a filter. That's it. That's new filters formulas. Let's see. Oh, hey, fabulous. I'll take that. I'll take that. So what are the two kinds of DAX subformulas? Per row formulas. This is argument 2 of an iterator. This is a subformula that runs once per row of a temp table, or a per row formula, a formula that runs once per row, right? The other kind is new filters formula. This is a new filters formula, a subformula that runs with a new set of filters. This is argument 1 of calculate. This is some subformula that you want to run after you change the filters. And that's really all you do with the calculate function, is change the formulas and then run some subformula. That's all you can do with it. Okay, so what's with the non-technical names? I haven't heard these before, Brian. So when I'm working with students, it's very difficult to tell them what they're writing. And by that, I mean, I say, okay, go ahead, start writing sumx. They get this far, and then they've got a blinking cursor in argument 2 of sumx. And they say, okay, Brian, you've told me to write sale quantity times sale price before. I understand that that's what you want me to do. I understand that I'm supposed to type those things. But what am I typing, right? If I tell people that they're writing a per row formula, I wouldn't say that they instantly get it, but people's heads nod a little bit. They say, all right, I kind of get it. With calculate, they're writing calculate, and they say, okay, I've got a blinking cursor here in argument 1. I know I'm supposed to type something like count rows or sum, but why? What am I typing here? What you're typing is a new filters formula. Students say, all right, is it a formula that runs with new filters? It is a formula that runs with new filters. Okay, I don't get it 100%, but I get it maybe 20%. By contrast, if I use more technical names and I say, oh, for sumx, argument 2, well, everybody knows that argument 2 of sumx is a multi-row contextualized scalar value or subexpression, and anybody that has made it through first grade knows that argument 1 of calculate is a filter contextualized scalar value subexpression. People just feel dumb, right? These definitions are very, very accurate, and it's important to have accurate definitions, but accurate definitions are not terribly instructive for new students. So for new people, you have to have a ladder in the step ladder that's in between the super accurate definitions, something that folks can understand. That's why I use these friendlier names. Eventually, after you fully understand a per row formula and a new filters formula, then you can start trying to figure out how this sentence makes sense to any human being anywhere ever. But don't do it until then. Once you're like, okay, I really understand the idea of a new filters formula or a per row formula, then you can work on tackling the more advanced language. Okay? So that brings us to formula decomposition. Right? Nice friendly way to sort of round out our Wednesday afternoon. What do I mean by formula decomposition? So to help us understand this idea of subformulas, we could visually break them out into their own little boxes. What does that look like? So here I've got one big formula. I've got sum x, sale, comma, and here I've highlighted the per row formula. Now, if you're a DAX expert, inside your mind, you're doing this all the time. Whenever I click on argument 2 of something like sum x, I immediately, in my mind's eye, highlight the whole thing and say, that's my per row formula. That's how I'm able to read things really, really fast and easily. Most folks don't have that skill. So to help you out with it, what we could do is we could take this rectangle right here and actually pull that subformula out into its own little rectangle. We say this is sort of the main formula, and inside that main formula, the subformula, we're going to pull it out into its own little box. That way you can really understand that this is sort of a top-level formula, and this is a subformula hanging out inside of it. Also, one benefit of this is, even though it's a little harder to look at when you first start, if you soften your eyes a little bit, what you'll notice is that the stuff in here, there's just not very much stuff in this box. And there's not very much stuff in this box. How do DAX experts look at a big, long formula and not get overwhelmed by it? They can look at it in chunks because they can see the little subformulas and only focus on one subformula at a time. The subformulas usually aren't very long and are a whole lot easier to understand. Okay? So the decomposition process makes the subformulas bite-sized and easier to understand, like that guy just said, who I'm listening to right now. Okay, so this is especially helpful when you're dealing with longer chains of subformulas. So if I look at something like this, which is a bit more advanced, where I've got one big formula, where I've got a subformula, a per row formula, and inside that subformula, I have yet another subformula, a new filters formula. By breaking it out, it's really easy to see the chain of how these subformulas work with each other. We got this guy here, which sets up this subformula, and this subformula sets up this subformula. And each individual box is not too scary. Okay? Each piece is bite-sized and easy to read. There's another reason this is useful, though, but before I can tell you what it is, we got to do a review things. It's important to do review things. Okay? Takeaways for subformulas. There's two kinds. The per row formula is a subformula that runs for each row of a temp table. This is always argument 2 of iterators, or almost always argument 2 of iterators, right? So if you type in something like sale, sum x, sale, comma, blah, 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 blah is whatever you want DAX to do for each row of the table you described in argument 1, right? The other kind of subformula is a new filters formula. This is a subformula that runs with some changes made to the filters, right? This is argument 1 of calculus. So, and then there's other places too, but pretty much always argument 1 of calculus where new people are going to see it. So when you type in calculate and you go to type in argument 1, what are you typing in? You are writing a subformula that will run with new filters, a new filters formula. Okay. The decomposition process is a technique that we can do to take a big formula and break it up into little bite-sized chunks where each subformula gets its own little rectangle so we can see them separated out. Okay. Any questions about this before I go on to the next phase? Let's say, with Brian DAX in PowerPoint is clearer than DAX in Power BI. Yeah, I'll take that. I'll definitely take that. Let's see. Okay, so evaluation context. Guys, we made it to evaluation context. Hooray, we're only, oh boy, like an hour and a minute. That's okay. I told you we had to set stuff up. It was kind of fun, but we made it. So now we can actually talk about evaluation context, finally. Okay. So every time a subformula or formula runs, it does so with a pair of lists in place. So if we've got this where we've broken out our little subformula, and here we've got this where we broke our little subformula out here, every formula or subformula, every little rectangle has at least one pair of lists associated with it, right? So here we've got these two lists, here we've got these two lists, and here we've got this pair of lists and this pair of lists. Boy, what's going on there? So the idea is that for every formula or subformula, it has these lists because these lists contain important information that the formula or subformula might need to come up with the correct number, right? Each pair of lists is given to the subformula by its parent function. And by that, I mean this pair of lists here, this was created by the calculate function. Calculate said, hey, new filters formula, when you run, go ahead and use these lists. New filters formula says, okay, you got it, right? So here with SUMX, when SUMX has this subformula over here, it says, hey, per row formula, here's two pairs of lists. You're going to need these to come up with the correct answer. And the per row formula says, thank you, that's very helpful, right? Okay, so each pair of lists was generated by the parent function. So the parent function is essentially using these lists to hand down important information from the parent formula to the subformula, right? So you can think of it, the parent function says, hey, subformula, you're going to need some information. Don't worry, I wrote it down on these two lists. Here are these two lists. When you go out there in the world to like strive and survive, you can use these lists to go do stuff. What is the name of these lists? The first list is called row context, and the second list is called filter context. Row context is a list of all the values in the current row. Filter context is a list of the current filters. And when you have a pair of these lists together, what do you get? You get an evaluation context. It's a pair of a row context and a filter context. So when you have those two books or lists together, you have enough information that a subformula can go run, right? Hooray! Yeah, you gotta have that slide in there. Okay. So every time a subformula or formula runs, it does so with a pair of lists in place. Each pair of lists is called an evaluation context. So here we've got this evaluation context. It's got two lists of information that this formula might need. Here we've got this evaluation context, which has two lists that this subformula might need, and so on and so forth, right? So every time a subformula runs, it's got these pairs of lists where this important information is written down. Yeah, Brian, this is still kind of vague. What do these lists look like? Well, you can't see them, but let me give you an artist rendition, right? So evaluation context is a pair of lists where important information is stored for a subformula to use. And they might look something like this, if you could actually see them. Row context looks like this. This is a list of all the values in the current row. So if I have a row context that looks like this, what I could say is in the current row, there's a column called sale shift, and it has the value of lunch. There's a value called sale, or a column called sale quantity, has the value of 1, and so on and so forth. So all the values of the current row are simply written down in the row context, right? What about the filter context? The filter context is a list of all the current filters. And like I told you before, in DAX, filters are tables, and so that list looks like this. Hey, right now we've got two filters that we need to apply, this filter and that filter, right? Okay, every item in the row context I call a current row value. Every item in the filter context in each one of these lists I call a filter. Easy as that, right? Okay. So if you want to push up your glasses for a second and say, hey, Brian, you said that these are lists. Is that okay? So you're saying that it's not it's not like an array, or it's not a record, or it's not some other fancy computer science thing. Maybe it is, maybe it isn't. I don't know. That's not what I mean by a list here. When I say list, think a list like on your refrigerator. Like if you've got a list of groceries, or a list that has like the plumber and the TV repairman and that kind of stuff. Those kinds of lists, a nice simple list that you might see on your refrigerator, okay? Okay, so what do you use row context for? So let's say we have a subformula that looks like this, where it says sale quantity times sale price. So the idea here is these references to sale quantity and sale price, DAX is going to say, oh, hey, what we're saying here is there's some values in the current row, and we want to multiply them together. We want to, from the current row, get the sale quantity and multiply it by the current row's sale price. So in this subformula, it looks in the row context and says sale quantity, hey, that's the number 1. Sale price, hey, that's the number 8, right? And so those two things together, it multiplies 1 times 8, and it gets the number 8. That's what row context gets used for. You're using the values of the current row almost like cells in an Excel formula, right? So sometimes the values in the row context, I have little R's next to them. The idea is, if you remember like a while back, I said that there's this thing called the super lookup or table expansion, where you kind of look up these extra columns into our copy or left join them into your copy. When those columns show up in the row context, they're considered related columns. Since the word related starts with the letter R, that's why they've got these little R's next to them. And if in a subformula you want to grab a value out of the row context and it's from a related column, what do? Use a function called related. And you say, hey, I want to go get a value for dish cost, but by the way, it's a related value, so go ahead and look for a little R next to it. DAX says, you got it, there's dish cost. It's the number 5, and so sale quantity times related dish cost. Well, that's 1 times 5, and it produces the number 5, right? Okay. Generally speaking, you grab numbers from the row context and add them together or multiply them together because most of the time people want numbers, but you can use the text strings if you want to. So if we've got in the current row sale dish and it's equal to the text string burger, we could have in a subformula, we could say, hey, go get that value burger and use the upper function to make it uppercase. And DAX would say, hey, yeah, sure, I can go ahead and do that. This is basically the same exact kind of stuff that you could do with numbers and text strings in Excel. You could do with values in the row context. Okay? Questions about that? Okay. Let's talk about the filter context. What do you use the filter context for? Let's say our subformula has a table reference, like sale right here. Remember back at the beginning of this presentation when I said that when you type in the name of a table, what you get is a filtered copy of that table? So when you type in the name of something like sale, it's going to give you a filtered copy of it. How does it know which filters to apply? DAX wrote it down. It wrote it down in this list called the filter context. So when we go get a filtered copy of sale, it says, hey, which filters do I apply? These 2 filters right there. And then the filtered copy we get is just the lunch and house special rows. If there were different filters written down here in the filter context, the copy that we got would look different. Okay? Okay. So, row context. It's got numbers and text that you use for Excel style use. Filter context. It's got filters that you use for things that involve auto filtering. Okay. So, how does stuff get put into the list? Before I go into that, I do see a question in here. Let's see, expanded table concept. Yes, absolutely. Thank you, Cindy. Yeah. Expanded tables at the core of DAX, understanding how they work. Absolutely, yes. So if you don't you can write DAX without understanding expanded tables. It is possible. Lots and lots of people do it. Most folks that use it don't understand expanded tables, and they write DAX that works. But if you want to know why it is that number is responding to the slicers, you have to understand expanded tables. So it's that expansion of the tables or that super lookup that adds all those columns that let the filters come and attack from different tables. That's how the thing works. Very, very important. Anytime a number moves, it's using that expanded table concept or that super lookup concept, whatever you want to call it. Okay, Brian, we got these lists, row context and filter context. Who puts the stuff in the list, right? Let me show you how the stuff gets in there. If you remember, I said that the parent function builds the pairs of lists. So let's say we got the calculate function here, right? And it's got a subformula, the new filters formula, right? Well, calculate has these this evaluation context here, 1 row context and 1 filter context. So calculate is going to build a new pair of lists for its subformula. So the first thing it's going to do is it's going to make a copy of the list that it's sort of looking at when it gets called, right? So it says, all right, I've got these values in the current row. These values are the current filters. I'm just going to go make a copy of those. And then calculate says, okay, what's argument 2? What changes am I supposed to make to the filters? Oh, right here it says to remove any filter on sale dish. So calculate looks in the filter context list and finds any filter on sale dish. If it finds it, it gets rid of it, erases it from the list, gets a big old eraser and removes it. If there's no filter on sale dish, it doesn't do anything, right? Now that it's got these copies of the evaluation context over here, where it's removed any filter on sale dish, it hands them, it eventually hands them, it hands them to the subformula, and now the subformula can run with this new evaluation context where that filter has been removed, okay? This is a little vague still. Can you make this more concrete, Brian? We'll have to try. Let me see me try, okay? So let's imagine we've got a measure called total transactions all shifts. And we've got 2 slicers down here. One, the user has clicked on a slicer for lunch, and another one for 8 special, which if you remember is the hamburger, right? Never a good sign in a restaurant. So how does this total transactions all shifts measure work? Well, it uses the calculate function, and it does this count rows thing, if you remember that, we're going to count rows of a filtered copy of sale, and then it says, comma, remove filter sale shift. So the hand-wavy version of this is calculate's going to remove any filter on sale shift and then run this subformula. But let me not wave my hands, or let me wave my hands and also show you what that looks like. Okay, so we're going to start with our measure here in a box, a single little rectangle, and we're going to take that subformula, the new filters formula of calculate, and we're going to pull it out into its own little box over here like that. There we go. So now we can see the main formula, and we can also see the subformula. We're going to separate these because each one's going to have its own evaluation context. And by putting them in these different little partitions with the little vertical lines right there, we can keep track of the different evaluation context. Speaking of which, let's think about the default evaluation context for our measure, right? If you'll remember, the user clicked on lunch and how special, that hamburger, right? Because the user has clicked on these two things in the slicers, that means the initial evaluation context has one filter for lunch and one filter for how special. This is the default evaluation context for the measure, right? Populated by those slicers right there. So what does calculate do? Calculate says, hey, I've got this subformula. It wants to run, but before it can run, it needs a pair of lists that has information about what's in the current row and what's in the current filters. So what I'm going to do, what calculate's going to do is make a copy of this evaluation context with a change made. What change is it going to make? It's going to remove any filters on the sale shift column. Well, if you look here, let's look at this filter. This is on dish type, so that filter will be okay. What about this filter on lunch? The lunch filter is on sale shift. Oh, yeah, we said to remove any filter on sale shift. So when calculate makes the copy, it's going to remove that filter right there. Goodbye. Let's see what that copy looks like. Okay, so calculate produces this evaluation context, right, with a new set of filters. Notice the filter for lunch is gone. Why? Because we told it. We said, hey, when you make that new pair list, be sure to remove any filter on sale shift. And it said, you got it, boss. And now we've got this new evaluation context made specifically for the new filters formula, the sub-formula of calculate, right? So now with these pair of lists set up, the new filters formula can run. And when it does, we're going to count the rows with the filtered copy of sale. What does the filtered copy look like? Well, there's one filter for how special. And so if you look at our filtered copy, it's filtered down to how special. Now, it's not filtered down to just lunch. Even though the user clicked on lunch and how special, we specifically said remove any filter on shift, which gets rid of the filter for lunch. And so when we get this filtered copy, it's happening in this evaluation context, not the original evaluation context. Over here, that filter for lunch is long gone, which is why we get rows for both lunch and dinner. When we count the rows of it, what do we get? We get the number 3 because there's 1, 2, 3 rows. And that number 3, by the way, is what we saw in Power BI. That's where that number came from. Okay. Oh, pause. Questions about that? Going once, going twice, 3 times. Okay, no questions. How about adding a filter, Brian? Like I showed the removing the filter example because remove filter is an easy thing to understand, but like I don't want to remove filters most of the time. I want to add filters. I get more power by adding things. Let me show you how you add a filter. Let's imagine, hey, how do you do that? Let me show you, right? So let's imagine that we've got a card that looks like this. The name of the measure is total dinner transactions, and the user has not clicked on a shift, but they have clicked on H special. That's the how special, that burger, right? So total dinner transactions, the name of that measure indicates we should just be looking at dinner rows. So we're going to have to somehow introduce a filter. Well, here's what that's going to look like, right? So total dinner transactions, it's going to use the calculate function. It's going to have this new filters formula. This is the sub-formula that will run after we make some changes to the filters. What change are we going to make? We're telling DAX to add a filter for dinner. Wait, Brian, what do you mean? How does this tell DAX to add a filter for dinner? Well, let me do a quick aside, just so it'll make a little more sense, right? So here's a brief aside. In DAX, if you use little curly braces, anything in between those curly braces produces what I call a quick table. It's just a quick way to produce a temp table. So if I create a text string for dinner and then put it in curly braces, DAX says, oh yeah, they want a temp table that looks like this. It's got one value in it, dinner. Where to get the name value for the column? I don't see it saying value anywhere there. When you use these curly braces, it just gives the column name of value because most of the time with these quick tables, it doesn't matter what the name of the column is, right? So with little curly braces, we get a temp table that looks like this. Here's the thing though. we want to give a temp table to calculate and say, add this as a filter. And we could give calculate this temp table, but this temp table as it stands will not do filtering the way that we want. The way filtering works, if I'm simplifying a little bit, is that it matches on column name. And right now the name of this column is value. We want to filter on the column called sale shift. So we have to have some way of renaming this column. How do we do that? We're going to use a handy little function called treat as. So if it's the stuff in the curly braces produces this temp table right here, we put that in this function called treat as, and we say, hey, to see this temp table right here, I want you to rename it so that the column name is sales shift, right? So treat as is a little more complicated than simply renaming columns, but for new users, that's how you should think about it. It is the function that renames columns so that you can use them as filters. So by doing this little snippet of code, we produce a temp table that looks like this. Hey, if I could get calculate to add this into the filter context, it'll act as a filter on dinner, which is exactly what we're going to do. Exactly what we're going to do. Oh, yeah. Thank you for joining. Thank you for joining. Okay. So let's go see how calculate changes filter context. So here's our measure again, total dinner transactions, count row sale. There's our sub formula, right? So the first thing I want to do is I want to take this sub formula and pull it out into its own little box over here. So we can see the parent formula and the sub formula. And now I want to think about the initial evaluation context for this guy over here. So the initial evaluation context is populated by slicers. The user clicked on how special, but they didn't click on lunch or dinner. So what's the initial filter context look like? There's a filter for how special, and there's no filter for lunch or dinner. That's the initial evaluation context. So calculate says, I need to go create a new pair of lists where I make some changes to the filters. What change are we going to make? Well, that's argument 2. So argument 2 is a set of instructions that produces a temp table. So just like I showed you before, what we've got typed out here, that's going to produce a temp table that looks like that. Sale shift is the name of the column, and it's got the value of dinner. If we could add this to the evaluation to the filter context, it'd be a filter for dinner. So when you take a temp table and you give it to calculate, calculate says, oh, I bet they want me to add this to the filter context. So when calculate creates a copy of the evaluation context, it's going to add this as a filter. It's going to do it right over here. Let's see it. Hey, check it out. This is the new evaluation context that calculate built. It took the original, it made a copy of it, and then it added this filter for dinner. Why a filter for dinner? Because we said, here's instructions for building a temp table that looks like this. And calculate says, oh, yeah, when you give me temp tables, I add them as filters. So now for our sub formula, we're counting the rows of this filtered copy as sale. We now have 2 filters in place, not 1, but 2, right? Because calculate built this new evaluation context where the list of filters has an extra entry in it, okay? So now the new filters formula is going to run. We're going to count the rows of a filtered copy of sale. What does that filtered copy look like? Well, now we have a filter for both house special and dinner. And so what does our filtered copy look like? We just get 1 row, the dinner house special row. So when we count the rows of this temp table right there, we get 1 because we're counting the rows of the house special dinner rows, not just the house special rows, okay? Okay, and that's how we get the number 1, which is what we saw in Power BI. Okay. So, any questions about that before I move on to iterators? And if you give me questions, I can't read them.
Yeah, I've got one question.
Yeah, sure. What do you got?
Yeah, I'm just looking at what you just wrote with the treat as. I'm not really, I've never really used that before. Functionally, it looks like it's going to behave similarly if you put it a filter,
Yep.
you know, shift equals dinner. Would it do the exact same thing?
Yes, it does the exact same thing. I've got a big long blog post about why I teach folks this version. So when you type in here, I'll just pull this up. I'm going to pull up Notepad if I can find it. So let's do calculate. And we're going to do count rows like that. And you say, yeah, Brian, you could do it this way, but the way I usually see it is something like this. Right, that's the way you usually write it. Like that's the way I usually write it too, for what it's worth. So not wagging the finger or anything. So something like that. Yeah. So when you do this, this works. It absolutely works, and it absolutely does the same thing. There's I don't know if trick is the right word, but there's a conceptual catch. So when you use calculate, you can use a function like remove filters. But if you want to add a filter, you have to give calculate a set of instructions for a table for it to build to add as a filter. This by itself is not a set of instructions for a table. The reason it works is when you type in this, DAX immediately rewrites it. It immediately rewrites it to that.
Yeah, yeah.
So this, from a user point of view, some person who isn't like me, like a regular user, looks at DAX code. It's a lot easier to explain what this is trying to achieve. However, the way that it works is that this is getting rewritten into this longer statement. This is a complete set of instructions for producing a temp table. This absolutely works. This is the way that it works, is DAX essentially fills in the blanks for you. The reason I like the treat as method is that it gets people thinking about the tables, the little rectangles in their head. But you're absolutely correct. All three of these work. There's no performance difference. They're all equally fast. They all absolutely work. Use whichever one you like. Is that a good answer?
Yeah, that's exactly what I was looking for. Thanks.
Perfect. You got it. You got it. That one took me a while to learn. Okay, so let's see. Hey, where was I? Oh, no, it's all these things again. I showed you that. So let's talk about iterators. So the way iterators work is that we've got our main formula. We've got that iterator function like SUMX. We give SUMX instructions for producing a temp table. So here where we type in sale, we're saying, hey, go get a filtered copy of sale. It's that filtered copy. It shows up over and over and over again, right? So there's our filtered copy of sales, right? It's the expanded version of it with those extra columns added and filters applied. So when SUMX gets this temp table, what it says is, hey, for my per row formula, I have to create one evaluation context for each row of this table up here. So what SUMX does is it says, all right, I'm going to start by making several copies of my current evaluation context. So it makes, in this instance, it makes 2 copies because there's 2 rows right here. If this didn't have 2 rows, it had 2 million rows, the SUMX function will make 2 million copies of the evaluation context. Works faster than you think, but for every single row in that temp table we give it, DAX is creating a new evaluation context. Or to be more specific, the SUMX function is creating a new evaluation context. So SUMX says, hey, my per row formula needs to run once per row of this table. Well, when the formula runs, there's a special place where we write down what are the values of each row. It's called the row context. So SUMX creates 2 copies, and it's going to write down the values from row 1 in the row context of this copy, and it's going to write down the values of row 2 in this copy, right? So the values of each row get added to one of our copies. So the values for row 1, they get written down in this row context, and the values for row 2 get written down in this row context. And then the SUMX function says, hey, here you go. Here's not 1, but 2 evaluation contexts, 1 for each row of the table that I gave you. In each evaluation context, I have written down the value of that row. So if you want to use the values of the row to like add them together or multiply them, hey, they're written down in this handy list for you, okay? So then the per row formula says, okay, I'm going to run once per row. And by running once per row, what I'm really going to do is I'm going to run once in this evaluation context and once in this evaluation context. And each one, I'll have the values of each row written down for me so I can use it. Brian, again, this is hand wavy. Can you make it more concrete? Yes, I can. Or I could try. All right, so how does SUMX change row context? Let's make this more concrete. Let's say we've got a measure called total sales. It is returning the number 32, big 32. We have clicked on lunch and house special, right? What is our formula? This is like the hello world of DAX, or maybe not the hello world, but whatever comes after hello world, right? A reasonably simple formula. We're going to do SUMX. We're going to say, hey, SUMX, here's a copy. Go get a filtered copy of the sale table, and I want you to run this subformula for each row of that table, right? So let's see how that works mechanically.
And Brian, I'm interrupting you,
Please
but
do.
the crowd is asking us to move back a little bit. Steve, I'm not sure, this was about 3 minutes ago when you asked this question when Brian was helping Julio, but what happens when the slicer for shift is applied?
What happens when, okay. I think I got you. So I'm going to go back to this example, right? So I think the question is, hey, let's say that because you're making things a little too simple, Brian, right? In your example here, the initial evaluation context has a filter for house special, and it has no filter for shift. So it's really easy to see what happens because dinner gets added. What if the user had clicked on lunch? What happens then? First off, I'll pause. Is that your question? Give me a thumbs up or something. Yes, fabulous. Okay, so I don't have it illustrated, unfortunately, but here's the idea. So if I had clicked on lunch, make sure I'm getting my example right here, right? The initial filter context would have a filter for lunch and house special. When we then say, okay, here's this filter that we want to add, Calculate would say, well, wait a minute, there's already a filter for lunch in there. You just handed me this filter for dinner. By default, if you don't do anything else, if there's a conflict between the filter that you want to add and a filter that already exists, it gets rid of the filter that already exists. So the end result would look exactly like this, and it would produce the exact same number, right? So when you say, hey, Calculate, here's this temp table added as a filter, it says, all right, I'm going to add this as a filter. I'm going to look in the existing filter context. If these are in conflict, the old one loses and the new one wins. It assumes that what you're telling it to do is the one that you want. Brian, I don't want that. I think you probably do. But still, Brian, I don't want that. Is there a way to turn that off? Yeah. If you wrap your instructions for producing the temp table in a little function called keep filters, what that function does is it attaches like metadata to the temp table and says, hey, Calculate, when you add this filter, if it conflicts with an existing filters, don't remove the old one. Just keep them both. In that situation, if you did that, you would have one filter for house special, one filter for dinner, and one filter for lunch. What would you get if you counted the rows in that situation? Well, it would filter down to just the rows that are both house special, but it would apply a filter for lunch and then apply a filter for dinner. How many rows are both lunch and dinner? None. The shift can either be lunch or it can be dinner. And so the table that you would get back would have 0 rows, and it had no rows. And so the result that you'd see in Power BI would be blank. It would say, I don't see any rows. You filtered them all out. Okay, I think I answered your question and answered a whole bunch of stuff that you didn't even ask me. Does that cover it pretty good? Perfect. Okay, I'll take that. Where were we? Okay, let's talk about iterators. Hey, we already did all this stuff. Isn't this fun? Okay, so we're going to start with our measure here, right? And so we've got this subform. This is a per row formula to help us keep track of it as a subform. We're going to pull it out. We're going to decompose it into its own little rectangle. And we've got these little partitions because each section has different evaluation contexts, right? So. Thank you. I appreciate that. So for total sales, let's think about the initial evaluation context. Well, it depends on what the user has sliced down to. Other stuff too, you can do pageable filters, but let's just focus on slicers. It starts basically with what slicers the user has clicked on. So the user has clicked on lunch and house special. So the initial evaluation context looks like this. It's got these two filters, and there's nothing in the row context. If you follow my blog, I'll explain to you eventually why there's never anything in the row context. For right now, trust me, there's never anything in the row context when a measure starts running, right? So what's going to happen is the SumX function says, hey, I've got this per row formula. It needs to run once per row of this temp table that's defined right here. What does this give us? It's a filtered copy of sales. So we've got those two rows because we're looking at the lunch house special rows. So this formula needs to run once per row of this temp table. Now, the thing is, the subformula, it can't actually see the temp table. It's not allowed to. I could get into why, but the short answer is it can't see the temp table because there's a special place where the values of each row are written. That's just sort of how DAX works. So when SumX wants us to run for each row of this table, what it needs to do is it needs to take the values of each row and write them down somewhere, right? Where's it going to write them down? In two new evaluation contexts. So SumX says, hey, I'm going to go ahead and create two new evaluation contexts. One's for the top row and the other one's for the bottom row. So it makes two copies of this. And in the first copy, it takes all the values of the top row and writes them down. And in the second row, it takes all the values of the second row and it writes them down, right? So now when the per row formula runs, it's going to run in two separate evaluation contexts, one for each row. And each one has the values of that row written down. So I'm going to run the per row formula twice, once in this evaluation context and once in this evaluation context. So let's see what we get. When we run this subformula in the first evaluation context, we're multiplying sale quantity times sale price. Well, in that first evaluation context, sale quantity is equal to the number 1, and sale price is equal to the number 8. So 1 times 8 is the number 8, which is, by the way, the number that we want for that first row. When we run that exact same formula in the second evaluation context, sale quantity times sale price, those references to sale quantity and sale price point to different numbers. because in row 2 in this evaluation context, sale quantity is the number 3 and sale price is the number 8. So we're going to multiply this time 3 times 8, sale quantity times sale price. 3 times 8 is 24, and so that is our answer for the second row. So 8 is the answer for the first row, 24 is the answer for the second row. What does the sum x function do with the numbers 8 and 24? It sums them up. If it were the average x function, it would have averaged them up. If it were the max x function, it would max it. If it were the min x function, it would min it. If it were the median x function, it would take the median. Everybody just uses sum x most of the time. And sum x, what does it do? It sums them up. So 8 plus 24 is 32. And by the way, that is the number that we saw in Power BI. Okay. Okay, so let's see. Do I have time for one? I'm going to do one more example, but I'm going to do it kind of quickly. One more example at a time. So we've got this time. This time we're going to do total cost. And we've clicked on dinner and not the house special hamburger, but the regular dishes, which for those of you who don't work at this restaurant, that is pasta and salad. Okay. So let's see how this works. So to get total cost, we're going to do kind of the same thing. We're going to say, hey, sum x. Here's instructions for building a temp table. Run this per row formula for each row of it. Let's see how this per row formula works. And it uses this weird related function. Let's see how this works. Okay. So there's our total cost measure. First thing we're going to do is we're going to decompose it, pull that subformula out into its own little box. So we can see the main formula and the subformula and understand them as distinct things that are related, but are distinct. They're different, right? Okay, so now for total cost, right, our main sort of top level formula, let's think about the initial evaluation context. These are clicked on dinner and regular. So the initial evaluation context has 2 filters. This time it's got a filter for dinner and another filter for regular, because that is what the user clicked on. However, the sum x function says, hey, I've got this per row formula. It really wants to run, but before it can run, it needs to have a set of evaluation context that will tell it what's in each row of some temp table. Which temp table? Whatever we typed into argument 1. So here where it says sale, that gives us a filtered copy of sale. Boom, there we go. We get that filtered copy that's expanded. It's got those extra columns added on there. Notice we've done this table expansion or super lookup, where we've left joined or VLOOKUP all the columns from dish onto our copy. And we're just looking at the dinner regular rows, right? Just dinner and regular. So sum x is going to have this run for each row of this table, once for that row and once for that row. The way that it works mechanically is the per row formula can't see the table. All it can see is the evaluation context handed to it by sum x. So sum x takes this evaluation context and says, hey, there's 1, 2 rows in this temp table. I'm going to create 2 new evaluation contexts, 1 for each row. I'm going to take this one where I make the copy here, and I'm going to write down all the values from row 1, right? There they are written down. And then all the values from row 2, those get written down in the second evaluation context. Notice in these evaluation contexts, some of the values have little R's next to them. That's because these come from the related columns, the columns that got added during that super lookup, VLOOKUP, left out or join table expansion, whatever you want to call it. These extra columns that get added by DAX just so the auto filtering works, these are visible in the row context, but you can't use them by default unless you add a special function to your per row formula. That sounds complicated. Basically, the idea is if there's a value in your row context and it's from a related column like dish, ID, type, or cost, you can still use it. You just have to wrap your column reference in this function called related. Related says go look in the row context for a column called dish cost. But when you do, be sure it has a little R next to it. Go check in the section where the little R's are, right? If you don't have the related function, it won't find it. With the related function, it can find the values with the little R's, right? So now the per row formula is going to run in this evaluation context and in this evaluation context. When it runs in this evaluation context, sale quantity times related dish cost. Well, sale quantity, that's just the number 1. Related dish cost, so the dish cost column, but like with a little R next to it, well, that's the number 6. 1 times 6. 1 times 6 is 6. That's the value for row 1. Now that exact same formula is going to run in the evaluation context for row 2 down here. And this time, the exact same subformula right there is going to point at 2 different numbers. Sale quantity now points at the number 2, and related dish cost points at the number 4. So 2 times 4, 2 times 4, which is sale quantity times related dish cost for row 2. 2 times 4 is 8. So we get 6 for the first row, 8 for the second row. What does the sum x function do? It sums them up. Again, if it were the average x function, it would average them. If it were the min x function, it would take the smallest one. What sum x, though, is the most common, and it adds them all up. So what is 6 plus 8? 6 plus 8 is 14, which is, by the way, what we saw back in Power BI, and also how Power BI came up with the answer. Okay, so that is how iterators work, right? We give it a temp table, and then it creates one evaluation context for each row of that temp table, and then runs the subformula we give it in each evaluation context. Hey, Brian, when you say it writes down these values, it's not literally writing it with a pen, but is it like literally writing it in memory? No, this is all done through pointers, which is why it's really, really, really fast. But when you think about it in your head, or at least when I think about it in my head, I think about it as literally just writing down those values. That way, each context, the row context and the filter context, is just a simple list like you might see on your refrigerator. Okay. Anything else? Is there anything else we need to know about evaluation context? Of course there is, but not in this presentation. We've been talking for like an hour and a half, so I got to stop. So this is me stopping. Hey, we covered all the basics. We did a really good job. Speaking of which, good job, everybody. Speaking of which, there's one last takeaway slide. Oh, no, it's like Lord of the Rings. I thought we were done. This is going to go on for half an hour. Not half an hour, just 30 seconds. Give me a second. Right? What are the takeaways from this whole big, giant presentation thingy, right? Every subformula runs with at least one evaluation context in place. An evaluation context is a pair of lists that hold useful information for the subformula. The row context is the list of all the values of the current row. The filter context is the list of the current filters. Calculate makes changes to the filter context so that a subformula will have a new pair of lists where the list of filters has been changed. Iterators create multiple evaluation contexts where the value from each row of some temp table gets written down in the multiple row context. That way, the subformula can go look and find the value of each row written down in that row context. And that, my goodness, is it. Thank you guys so much for joining me. You just finished watching DAX Physics 101, Demystifying DAX Evaluation Context. Congratulations. Any questions? Any questions?
Well, before we get to questions, can everybody come off mute? I know everybody's been congratulating the chat, but let's give Brian a round of applause. Way to go, Brian.
Thank you so much, Brian.
You're very welcome.
Great job, Brian.
Masterfully done.
Thank you. Thank you. Thank you.
Okay, now we can open the floor to questions.
Yeah, Brian, I think we can safely say that people are less scared at the end than at the beginning.
Gosh, I certainly hope so. Certainly hope so. And if you're like, Brian, that was fantastic. Is there a version of it where you don't squeeze all that stuff into 90 minutes? Yeah, it's called the blog. Go check out my blog.
Next time we'll have to tie your hands behind your back since, you know, you can already do it with one eye.
Yeah, well, I'll have this thing shoot little lasers and
That'd be sweet.
I saw you do this presentation before. I think it was for Ken Pohl.
Probably Reed. I've only done it twice. So if you saw it a third time, it was a doppelganger. But yeah, probably Reed.
Okay, maybe Reed. Okay. Well, I think you did a better job on this one. It's nice. Thank you.
Well, thank you. I appreciate that. Yes, second time's the charm.
Or it made more sense to me this time.
Okay, good. Yeah, sometimes repeated viewing is really, really helpful, right?
I see Fernando's asking, what do you think of the new DAX query view?
Oh, it's fantastic. I mean, I still like DAX Studio. I spend tons of time in it, but the DAX query view is really, really good because it can help. It's really useful if I want to go write. So historically, when I wanted to write a query, like depending on how complex I want it to be, I would go if it was complex, I'd go into DAX Studio and do it there. You get more bells and whistles. It's a really cool environment. If I wanted to do something quick and dirty, I would create a new calculated table, which is really bad, but it was so fast. That's how I did it most of the time. And then I would end up with this table that I had to remember to delete later on, or I have to comment it out or some goofy thing. Now, if I want to go query the DAX engine, I just go write it right in Power BI. And also what I'm explaining to students, hey, this is a language of queries. I can show you. I can go do the performance analyzer, scoop the query out of it and go write it right in there. And they say, oh, I get it. For every single table visual, it's just a query that gets executed and then gets drawn as a line chart or a column chart or a table. So short answer, I love it. I think it's really, really fantastic. Although not as cool as visual calculations. I think those things I'm so excited for those things. But they're both really, really awesome.
No more calculated tables.
Direct lake. Yeah. Well, yes. Not yet. But that's okay. Again, you use the query view and you're good. You got it. You got it handled. Other questions out there? I should say, for folks that were very happy with elements of DAX and are like, when are you going to produce more videos? I may have some good news coming down the pike. I may have used this content that we've been producing to set up a whole big, basically kind of elements of DAX 2.0. Shh, don't tell anybody. It's what I've been working on for the last month and a half like crazy. It's probably why I can't see out of this eye. So I hope you enjoy it when it comes out.
Sweet.
Any
Well,
other questions?
we
I
do.
see a hand up
Yes.
there.
Mr. Mark.
That's me.
Hey, Mark.
It's back on that tangent you took with the treat as function, and it's you had said it rewrites to the proper, DAX rewrites it, but you said there was no performance impact. But if it's rewriting it, if I just said X equals this, is there kind of a performance impact? Just because it has to rewrite, if I'm rewriting a filter.
Yeah, I mean, so technically speaking, like there is a, it does have to rewrite it, which takes, it doesn't happen in zero time, but the time it takes to rewrite that. So what's going to happen is whenever you write DAX, I'm diving a little deeper here, but that's okay. It's, a slightly deeper question, right? Whenever you write in DAX, it's always going to be translated to some flavor of SQL, right? That's why DAX is able to work in direct query mode. So if I connect it to MySQL or something like that, whatever I write in DAX can be translated to SQL. And even if I'm not in direct query mode, it's being translated to, I never get the name of this right, an internal version of SQL that's used by analysis services. I want to call it XM SQL, but that's probably not it. So when it looks at what you've got written in DAX, when it rewrites it, it has to rewrite it as some flavor of SQL anyways. So in that process, that's when it gets rewritten. So technically it takes a little more time, but the little more time is like less than a millisecond. It's so fast that the variations from your computer's performance going up and down are way, 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 way bigger than that. So, I mean, yeah, technically there could be some difference there, but you cannot measure it. It's so small, it is immeasurable. So,
so don't go rewrite any of my old ones, but just maybe reprogram how I think and maybe try to get into that mode. Be good practice.
Yeah, the big thing that I say is, let me kind of pull this up here. The challenge is, let's see, if I go to my thing, where do we go here? Yeah, so like whenever you see Calculate and you see something like this written here, let me maximize it so you can see it. So whatever you've got written for argument 2 of Calculate, I need you to see a little rectangle in your head, right? So I find for students, when I do it, show them this method, it's easier for them to see the little rectangle in their head. And they say, if they think, oh yeah, a filter for lunch is like a where clause, sale shift equals lunch, that's not how DAX thinks about it. And if you think about it that way, it's going to keep tripping you up over and over again. So when you see it written down, you have to see a little table. Now, I've gotten to the point where when I see this written in code, I don't see a little where clause-y thing where shift equals this. I see the little table floating above it in my head. Once you get to that point, you're golden. Do it any of the 3 ways that you like. If you're not at that point, you can rewrite it if you want to, if that helps you sort of see that rectangle. Or, frankly, I don't even care that much. You could just pause and say, wait, what did Brian say? He said, when I see this code written here in Calculate, I have to imagine a little rectangle. Okay, I'm going to imagine a little rectangle. I don't even know what it does yet. I'm just going to do it because Brian said so. Over time, you will start to use these little rectangles to track the filters in your head. So when you say what filters are in place right now, rather than keeping a text-based list, you could use little objects to keep track of them. It's going to use the part of your brain that just runs a little better for that kind of stuff. I'm sorry, I'm getting way off tangent here.
No, I like it. No, that's good practice. Thanks.
Sure. Let's see. The questions. Can you use DAX Studio? Can you use DAX Studio some other time to be showing the steps and interim results? Notes in dark mode. These guys here. I could sort of show them to you, but I'd be faking it. The challenge is some of the stuff that I've gone over today, DAX hides because it doesn't want you to see the complexity. Because it doesn't want you to see the complexity, you basically need a DAX expert to sort of walk you through it. So I could show you how this works in DAX Studio, and I could show you how the treat as function works in DAX Studio. But some of the stuff like this, I can't show you DAX literally rewriting it because that happens kind of under the hood. But I could say, like, in DAX Studio, if you were to type in fact, do I have it? Let me do it. Just for fun. Oh wait, you said some other time. Okay, sorry. Everybody wants to go home. Yes, I can show it to you some other time.
Great.
That's too long of a presentation. Everybody's got places to be. Yes, I totally could. Other questions?
Again, I think you just did such a masterful job, Ryan.
That's
You're gonna
right.
let everybody go to bed soundly tonight, knowing all their DAX questions are answered.
That's right. And I'm happy to do it. I always like it when people join me for DAX. I hope you guys had a good time.
For sure.